Okay, welcome to this deep dive. We're jumping into some really interesting source material you shared with us.
Yeah, it gives a great, maybe slightly surprising look at a fundamental math tool.
Exactly. Something you might be wrestling with right now if you're in calculus specifically, differentiation and integration.
And what's really, insightful here is how it takes these ideas, which can seem abstract,
Uh-huh.
and pulls them into a very concrete, practical setting. It's focused on one specific application.
Right, and that application is calculating total energy usage,
Yeah.
which, okay, you hear calculus and energy, maybe you think physics labs.
Or electrical engineering, maybe.
Sure, but this source puts the problem somewhere different. An agricultural produce processing facility.
Exactly that. Picture like a big industrial building handling vegetables or fruit, maybe.
Okay.
You've got conveyors, coolers, processing machines, stuff turning on and off all day,
Ah, so the power draw isn't constant, it's fluctuating.
constantly. And that's the challenge, isn't it?
Yeah, because if it was steady power, you just multiply power by time.
Right.
Easy.
Simple multiplication.
Yeah.
But if the power level is changing moment to moment,
How do you accurately get the total energy used, say, over a whole day?
precisely. And that right there is where the source shows the power of integration.
Okay.
Because energy fundamentally is the accumulation of power over time.
Right. Power is the rate of energy use, like the derivative of energy over time.
You got it. So if power, let's call it P, is the rate energy is used at any moment, P,
PT, the function.
exactly, P, then to find the total energy used over some time period, you need the tool that, well, reverses differentiation,
Integration.
integration. You integrate that power function, PT, with respect to time.
From the start time, T1, to the end time, P2. That definite integral.
That's the one. And it gives you the total accumulated energy. Geometrically, it's like,
The area under the power curve between those two times.
that's it, exactly. And the source makes it clear this isn't just theoretical. They use integration as the core method.
to sum up all those little bits of varying power consumption.
To get the precise total energy used. And that's critical for the facility.
Why specifically? Just knowing the total.
Well, think about managing costs, budgeting, pinpointing when they use the most power.
Ah, for optimization. Maybe scheduling maintenance differently.
Potentially, yeah. Or just making better operational decisions.
Yeah.
Simple estimates based on average power, they wouldn't cut it.
Not enough detail.
Right. You need the precision that integration gives you from that fluctuating power data.
And the source implies they're likely getting that PT function how? From sensors.
Seems likely, yes. Collecting real-time power data from various points in the facility.
Which might mean the PT isn't a nice clean equation. It could be messy data points.
Very possible, in which case they'd probably use numerical integration methods to approximate the integral.
So taking the theory and really grounding it in practical data collection and computation.
It really bridges that gap, doesn't it,
Yeah.
between the calculus equations you see?
And the actual day-to-day operational needs of a business.
Mm-hmm.
Even one focused on, well, farming products.
Yeah, it shows these fundamental concepts are essential tools for understanding and optimizing things in industries you might not connect with calculus right away.
So boiling it down from the source material, the big takeaway seems to be,
Well, that foundational math, like integration, it's not just for textbook problems.
no, it's actively used,
And-
solving complex, practical issues like getting a precise handle on total energy use.
In real places, like these agricultural processing facilities. And that helps them and makes smarter decisions, be more efficient.
And seeing it applied like this, it really underscores the relevance, the power of what you might be learning right now
Absolutely. It turns that integral symbol from, just a symbol on a page.
into a tool for measuring something real,
Yeah.
something tangible, even economically important.
Exactly.
Which really makes you think, doesn't it? If integration is this crucial for measuring energy in, say, a farm facility,
Mm-hmm.
where else?
Mhm.
Where else might these sophisticated mathematical tools you're learning right now be absolutely essential for understanding, for measuring, for optimizing the really complex world that's all around us?
That's a great question to mull over.
Definitely something to keep in mind as you continue your own deep dive into these powerful ideas.